A mysterious object from beyond our solar system has recently captured the attention of astronomers worldwide, challenging everything scientists thought they knew about the behavior of cosmic bodies. This object, identified as 3I/Atlas, has made an unexpected journey through the solar system, displaying behavior that defies current scientific models. Its acceleration, rapid speed, and lack of gas emissions are pushing the boundaries of astronomical understanding and raising profound questions about the forces and materials governing our universe. The arrival of 3I/Atlas, a surprising interstellar visitor. 3I/Atlas is what scientists refer to as an interstellar object, meaning it originated from outside our solar system and passed through it on its way through the galaxy. When it was first detected in October 2019, astronomers immediately noticed its unusual speed. Traveling at an astonishing 130,000 miles per hour as it entered the solar system, it was already moving faster than most objects that typically pass through our cosmic neighborhood. This high velocity set it apart from typical asteroids and comets, which generally enter the solar system with much lower speeds. At first, scientists anticipated that 3I/Atlas would follow a typical path, behaving like the comets and asteroids that frequently traverse the solar system. The motion of such bodies is usually well understood and predictable, governed primarily by the gravitational pull of the Sun. However, 3I/Atlas quickly began to exhibit behavior that no one could have predicted. The unexpected acceleration after perihelion after its closest approach to the Sun, known as perihelion, on October 29, 2022, the object displayed a truly puzzling phenomenon. Rather than following the expected trajectory and slowing down or continuing on its path at a steady speed, the object's velocity increased dramatically. By the time 3I/Atlas passed the Sun, it was accelerating to an astonishing speed of 152,000 miles per hour, a jump of more than 20,000 miles per hour from its original velocity. This unprecedented acceleration immediately set off alarm bells in the scientific community. For years, scientists have relied on a fairly predictable model of celestial mechanics to understand the motion of objects in space. When comets or asteroids approach the Sun, they're generally subjected to the Sun's gravitational pull, which accelerates them toward the center of the solar system. In most cases, this gravitational acceleration is balanced by the object's momentum, and the object continues along a roughly parabolic orbit, slowing down as it moves away from the Sun. However, in the case of 3I/Atlas, this behavior did not hold true. The object's speed increased in a way that could not be explained by gravitational forces alone. This deviation from the expected path raised significant questions about the forces at play in the object's trajectory. What could be causing this acceleration? The missing gas emissions. An unusual absence. One of the most intriguing aspects of 3I/Atlas's journey is the absence of any visible gas emissions. When comets approach the Sun, the increasing heat typically causes the volatile ices on their surfaces to vaporize, creating jets of gas and dust that form the characteristic comet's tails. These outbursts not only explain the bright, gaseous clouds that surround comets, but also provide additional forces that can slightly alter their trajectories. However, 3I/Atlas has not shown any of these expected signs. Despite its dramatic acceleration and close passage to the Sun, there has been no evidence of gas jets or a surrounding dust cloud. This lack of typical comet behavior has left astronomers and physicists baffled. The absence of such emissions suggests that 3I/Atlas may not be a comet at all, or if it is, it might be unlike any comet ever observed. Harvard physicist Avi Loeb has pointed out the significance of this missing gas. According to Loeb, if 3I/Atlas were a typical comet, it would be shedding a substantial amount of mass due to the heat of the Sun. This process would create a visible cloud of dust and gas around the object, which would in turn influence its motion. The fact that no such cloud has been detected means that either the object's composition is highly unusual, or the forces acting on it are unlike those observed in any known celestial object. The mysterious acceleration and its possible explanations, the increased speed of 3I/Atlas, after passing perihelion raises more questions about its true nature. To explain the object's dramatic acceleration, scientists have explored several theories, none of which fully account for the observed data. In conventional models of cometary motion, an object's close passage to the sun would cause it to accelerate, but this acceleration would typically follow a predictable pattern, peaking at perihelion and then gradually slowing as the object moved farther from the sun. However, 3I/Atlas did not follow this pattern. One possibility that has been suggested is that 3I/Atlas may be composed of an unusually dense or heavy material, which could explain why it was able to maintain its speed even as it passed the sun. Alternatively, it might be that the object is undergoing some unknown physical process that is adding energy to its motion in ways that current physics cannot explain. The lack of mass loss, an additional puzzle. Another key piece of the puzzle lies in the mass of 3I/Atlas. Scientists estimate that for the object to change its path as dramatically as it has, it would have needed to lose at least 13% of its mass during its close pass with the sun. In the case of typical comets, this mass loss is caused by the sublimation of ices on the object's surface, which is visible as a gas cloud surrounding the nucleus. This process releases energy and alters the object's trajectory, a phenomenon that has been well documented in cometary studies. However, 3I/Atlas has shown no evidence of such mass loss. There has been no visible gas or dust cloud surrounding the object, nor has it exhibited the characteristic outgassing behavior that would be expected from a comet experiencing intense solar heating. Without this mass loss, the object's rapid acceleration becomes even harder to explain. Theories beyond the natural. Could something else be at play? Given the anomalous behavior of 3I/Atlas, some scientists have started to entertain more speculative theories about its nature. Harvard's Avi Loeb has suggested that the object's acceleration and lack of observable gas emissions might point to an artificial origin. He has even proposed that 3I/Atlas could be a type of probe or device sent by an advanced civilization. This theory, while controversial, raises important questions about the limits of current scientific understanding and the possibilities of extraterrestrial intelligence. While most of the scientific community remains cautious about such extraordinary explanations, the mystery of 3I/Atlas has certainly sparked renewed interest in the search for extraterrestrial life and the potential for interstellar exploration. Could it be that this object is not just a natural visitor from another star system, but something more deliberate and designed? The absence of expected cometary behavior, combined with the object's strange acceleration, has led to increasing speculation about its origins, though no definitive evidence has been presented to support such a theory. Conclusion. Awaiting more data, the mystery of 3I/Atlas is far from solved, and scientists remain cautious in making any definitive conclusions. As the object continues its journey through the solar system, researchers are preparing for more intensive observation campaigns, hoping that more data will reveal the true nature of this unusual interstellar visitor. The object is projected to reach its closest approach to Earth in approximately 6 weeks, and astronomers are hopeful that this final close pass may provide the key to unlocking the secrets behind its strange behavior. While it is possible that future observations will explain the acceleration and lack of gas emissions through natural processes that have yet to be understood, the mystery of 3I/Atlas serves as a reminder of the vast and unexplored nature of our universe. As new technologies allow us to explore farther and observe more closely than ever before, it is clear that there is still much we don't know about the objects that pass through our solar system, and perhaps even more about the forces that govern the cosmos. As for 3I/Atlas, its journey through our solar system may soon come to an end, but its mystery will likely persist for years to come. Whether it is a comet, an asteroid, or something far more extraordinary, the object has captured our imagination and reminded us that the universe is far stranger and more complex than we could ever have anticipated.